Hello, I want to discuss the difference between impending tipping versus impending slipping. Remember that we here are in static, so we call it impending because there's no motion. So what we need to determine is if it's going to tip or slip. And in those two cases, there's two different assumptions, and that's what we'll discuss. So you can start by assuming that something is slipping, proving your hypothesis, and if it proves to be true, then it's slipping, and if it doesn't, then it's tipping, and then you prove that it's tipping. So this is an example of what we'll do. This is a box that needs to be pushed with a force P, and you need the dimensions of this, the height and the width of this box. And in this case, we have the weight of the box, which should be located at the centroid. So we don't know P, for example, and so we don't know which is going to be the friction force. We don't know where the normal force will be located, so we don't know the distance from the centroid where the normal force is. So we have one unknown, which is the friction force. We don't know the normal force, we don't know this distance, and we don't know the P, so it's four unknowns. And we only have three equations, so we need to add one more. So one of the equations is sum of the forces in x equals 0, sum of the forces in y equals 0, sum of the moments equals 0, and then if you have impending slipping, and that's why we start with impending slipping, because whenever it's slipping, that means that that friction force is going to be equal to the maximum friction force, which is equal to the friction coefficient times the normal force. So for impending, this condition is what happens, because you have overcome or are about to overcome this maximum friction force. Okay? So the difference between impending tipping versus impending slipping is that in the case here on the left, you have impending slipping, and this normal force is located a distance from the centroid. So here we have the P, the W, the friction force, the normal force, and then this distance. However, when it's tipping or about to tip, which is impending tipping, the normal force will be located here and it'll tip, because this generates a moment that will make it tip. So we'll see how we determine if there's impending slipping versus tipping. And again, the easiest way is to assume first that there is slipping, and then you calculate this x distance, and if this x distance is less than b over 2, then our assumption is correct. But if the normal, this x, proves to be larger than x, which is impossible, then you know that your assumption is incorrect. So in summary, whenever you assume slipping, remember this is your friction force, which is the maximum friction force, mu s times n, and then you only solve for x, p, and n, and your value of x has to be between 0 and b over 2. In the case of slipping or tipping occurs, then you know that x is going to be equal to b over 2. That's what you know. And then you calculate p, n, and f. And in the case of tipping, what happens is that, because if it's tipping, that means it did not slip, so your friction force will not reach that maximum friction force, which is mu s times n. Okay, so let's see it with an example. We have a crate weight of 250 pounds and a coefficient of friction of 0.4. So we need to determine what is that maximum friction force that can be applied without causing movement of the crate. So of course you have to draw a free body diagram to determine the unknowns. Make your friction assumption, so we can start by saying that there's slipping and then verifying if that is correct or not by applying the equilibrium equations. and then checking the assumptions. So first thing, free body diagram. We have it here. We have that force P, which is located at this distance. You have the 250 newtons, which is at the centroid of the box in this case. Unless otherwise specified, you have these distances, and then of course the 3.5. In this case, the center of gravity is a little higher, so there's that distance has been provided, that G, and this is very important. And so let's start by assuming that there is slipping. Okay, so assume impending slipping. So this is static, so impending, because once I get to that point where the friction forces equals mu s times n, then that's when impending slipping occurs. So sum of the forces in x equals 0. We have P minus F equals 0, and because I am assuming impending slipping, that means that this F equals mu s over n, so P equals mu s times n. And I still don't know n, so I need to see what is n. So I do some of the forces in y, and then I have negative 250 pounds plus n. I don't have any other, is 0. So n equals 250 pounds. So P equals 0.4 times 250 pounds, which is 100 pounds. So in this case, here I have 100, and here I have an opposite. So here I have my n is 250 pounds and P is 100 pounds. So seems right, seems logical. However, I need to determine this x to corroborate my hypothesis. So what I'll do is then do a sum of the moments about point O equals 0 to find that x, and if my assumption is correct, the x should be somewhere between 0 and 1.5, and if it's larger than 1.5, then I know that I have impending tipping. Okay, so I have 100 pounds times 4.5, and this is negative, and then I have the normal force, which is 250 pounds times x equals 0. Okay, so when I solve for my x, what happens is that my x here is equal to 1.8, and 1.8 is larger than 1.5. So the assumption that there's impending slipping is incorrect. There is incorrect assumption. Okay, no slipping occurs. Okay, so I'm going to see if there is tipping. Okay, so in the case that there is tipping, what I have is that the normal force will be located not here, but here at the edge. So this would be my normal force. That means that if there is impending tipping, then what I know for sure is that x has to be equal to 1.5 feet. Okay? In the case of impending slipping, all I knew was that the force, the friction force, equaled the maximum, which is mu s times n. In the case of impending tipping, this is what I know would have to happen. So now I'm going to do some of the forces in x equals 0. And of course I still have the same P minus F equals 0. But then now F is not the maximum friction force. So P equals F in this case. And sum of the forces in y equals 0. What I have is the normal force minus 250 pounds, so equals 0, so the normal force equals 250 pounds. So then my other equation, sum of the moments about O equal 0. So what I have is my P times 4.5, and this would be negative. And then I have positive moment, 250 times 1.5 equals 0. So then my force P equals 83.3 pounds. Now, whenever I look at this value makes sense because there's no slipping. The friction force that should be the maximum friction is mu s times n, so it should be 0.4 times 250, which is 100 pounds. And this is larger. This 83.3 is lower, or this 100 pounds is larger than 83.3 pounds. So then I know that there is tipping before there is slipping. So I hope this clarifies that. So looking at a little quiz here, just to understand really well when we have impending slipping. Here we have a block, and the block has a weight of 10 pounds. So we'll have a normal force in the opposite direction. What is the magnitude of the friction force? So if I do sum of the forces in y equals 0, then I have the weight minus the normal force equals 0, so the normal force equals the weight, which is 10 pounds. And then sum of the forces in x equals 0. What I have here is 2 pounds. And then this is going in this direction, so here's my friction force, minus F equals 0. So here is my friction force equals 2 pounds. So if I look at the friction force, the friction force would be 0.3 times 10, which is 3 pounds. And 3 pounds versus 2 pounds, so my friction force here is less than Fs, which is 3 pounds. So it's an equilibrium, right? It's not moving, no impending slipping, okay? Whenever I get this 2 pounds, instead of 2 pounds, whenever it reaches 3 pounds, then that's when I have impending slipping. And if it's more than 3 pounds, then of course it'll be moving, and then it's not statics anymore. We're in dynamics, unless the acceleration is still 0. Okay, so make sure you understand this concept. Finally, then there's the ladder, AB position as shown. What is the direction of the friction force on the ladder? Well, if the ladder is slipping, that means that it would be moving this way, moving down. So the friction force is always opposite to the direction of motion. So this is the direction of the friction. So it's D. I hope this helps. And make sure you practice your problems. Look at the online open initiative, modules from engineering, mastering engineering, examples, and assigned problems. Thanks.